Right, hello, welcome to a new video here on the Lötwig Fusel channel. I've made several videos, so I've made videos on real-time rendering, which I can only continue as soon as I have a framework ready to go. And I made some videos on multi-threading, which showed you how to multi-thread, but basically just showed the pure basics. So the library that I'm currently writing has no plans to do an extensive multi-threading support. It should give you multi-threading support, but it should be like you need to implement your own multi-threading. But at least the library should provide maybe some extractions for several classes. So for example, like a memory allocator, maybe the library should provide a like proxy for a memory allocator that can be used concurrently from multiple threads, so stuff like that. Or maybe just the core basics of multi-threading concurrent programming. So in this video I just thought that it may be quite good to give you a walkthrough while I'm writing the concurrent classes for ModernGX, for the library that I'm writing for real-time rendering. And basically the idea is that you kind of like learn how the library is being used while I write the library and you get a video, basically. So yeah, let's start. I don't know, I'm quite sure this is basically what was foundation, was basically more like that. So this is like core. So we have core concurrent. And I have a typo there, so let me fix this really quickly. So there we go, concurrent. Now we are up and running. So the first thing a concurrent application should provide is a lock. It's like the most simple thing you can do. A lock can have different implementation. It can be a mutex, it can be a SpinLock, it can be a retinant SpinLock and stuff like that. So actually not SpinLock, it's not called SpinLock, but it's called retinant lock. But we're just gonna implement a darn simple SpinLock, but we are also like implementing an interface so that we can create like all other classes that use locks within them. So for example, like janitor classes, so how do I call this, lock guard and guarded object, so basically an object that is guarded by a lock, so that these classes can like use any lock you want. I will basically use the ILog interface here, so that stuff is a bit easier. And yeah, we're gonna start by including our default stuff. I mean, like you can already see what's most of the time required. I'm just gonna copy paste this. Gonna use this one, but I'm gonna use the namespace here. It's kind of like pointless to do this. So MGX core. I don't have this in. What was it? Control Shift V. Yeah, there we go. Concurrent. Then you have kind of like this hierarchical copy paste. All right. So namespace MGX core concurrent is the namespace where everything is living on. Now I'm gonna create a class which is the ILog, which is basically the interface for logs. And yeah, we're gonna have a public virtual functions here, pure virtual functions. Actually not all pure virtual. We're gonna have a virtual void, or actually we have a virtual bool try. Or what convention did I go in this library? Did I go caps? The function names, yes, I go caps with the function names. So we're gonna have try acquire, because the lock can be acquired and can be freed, which will be const and 0. So basically this will try to acquire the lock and return the result. Pure virtual here. And then we will have a function that releases the lock, virtual void in this case, void release, no except, which should basically release the lock. And then we're gonna have a function acquire, but it's gonna be inline, so acquire function. Let me make this templated. So we're gonna have a template. Type name ft, which is a function pointer. Then we're gonna have a void acquire. I mistyped acquire. Acquire. Yeah, acquire is just written like that. Acquire. So basically a function, it's actually it should be inlined. I mean, it's probably gonna be inlined, but yeah. Let's write this acquire function. So we're gonna write while not try acquire. So while we are not able to acquire, we're gonna call our function pointer. Actually, we need to import this here function here, and then we just need to call this function. So basically, this means that we can kind of like provide a function that is kind of like telling what's going on there. Maybe let me set this by default. Actually, this would introduce some more checkings. Let's do a static function here, static inline function that is doing nothing. Static inline, no action. Wait. No except const, no except. Okay, actually const is not required if you go static. It's like garbage, and maybe we should do a... Yeah, actually we do not need to do this on this code. Yeah, of course, void. And what we're gonna do is nothing. Maybe let me collapse this to that. So basically this is a like mere function that does nothing. And now we could try to provide this as a default parameter. I'm hoping that this is working. We're gonna see if it will automatically deduce the default parameter, but I think yes. And it should also like optimize this away. But yeah, we're gonna try out what how this works as soon as we have the first log available. So let's write the log. We're gonna have a SpinLock here. Alright, so the header file is spinlock.h. Let me quickly copy this over. I mean, it's like pointless because I'm deleting like everything. But yeah, let me now include the log here. Include ModernGX core concurrent ILog. And we're gonna have the class SpinLock here. Just a public ILog. Class ILog? Yeah, now here is it. Alright then. So this is a line to a atomic user mode lock. It's again no longer knowing the lock. I don't know why it's doing that. So let's include atomic because we're gonna need atomics here, and we're gonna have a public, gonna have a private. First of all, a SpinLock has just a default constructor, and it cannot be copied. And maybe I don't know if I can. Yeah, I shouldn't move that as well. So let's yeah, like a construct, setup, default, delete constructs. I don't need a destructor because it's pointless on which state the log is. And then we're gonna have the implement interface here. Alright then. So first of all, privately we're gonna need an atomic flag. And this is the lock flag. So this is equal to std atomic flag. I mean, there is an init. Need to actually look this up. There is a init constant to set this flag to cleared. I mean, it's not required if you're going to C++20, but we're gonna just make this here to be 100% safe, and we're just gonna... Oh, it's actually expanding to that because we are we actually at CPP20? But yeah, it's okay. We are just gonna use this init here. Actually, this is like triggering me hard. Why is it not checking my ILog? I'm not quite sure why he doesn't like my ILog here. I mean, yeah, we have an ILog there. Is there an issue in there that it is not able to... I gotta see. I think, yeah, if I switch files, it's detecting that, and as soon as I start typing, it will forget it again. Alright then. Let's, yes, you see, I start typing and it's gone again. So, okay, great. So, bool, try, acquire, no accept, overwrite. Oh, this is not overwriting anything because I don't know the interface. Let's create the implementation. Try acquire is actually quite easy. We are calling test and set on our atomic flag for acquiring the lock, and this will return the old state, and only if the old state is 0 this will succeed, so we need to invert the result of test and set. Release will be also straightforward. We're gonna just call my log flag clear std memory order release, and we are good with that. Alright, so this should give us, now it's like liking that, but yeah, this should give us a proper implementation of a SpinLock. So let's try this out just by taking a look at the interface. This is no longer in existence. Concurrent, let's include the SpinLock here, and let's actually create an ILog MGX for ILog pointer, concurrent ILog pointer log, because I always like to verify that everything is working, and this will be equal to new MGX core concurrent SpinLock. Alright then, so of course I need to delete this at some point. I mean, even though I'm not gonna use the syntax while using the library, but let's just do this very quickly to see if everything is working, and let's try out the different things. So I'm gonna acquire the log at one time. And it does work, yeah, probably. So yeah, I need to provide a function here, a default tablet parameter probably. Yeah, so it's gonna be a void pointer. I'm not quite sure how I should. Damn. I know how to do the function pointers. Should be like something like that, just maybe. Yeah. I hope this is gonna compile. We're gonna see. So let's also release the log here and just see. Check it. Look at and set up 3 breakpoints up. Probably not gonna compile. It's actually compiling, that's interesting. Alright then, if it compiles, I'm good with that. Let's take a look at the log here. It should see that this is a SpinLock, and you can also see like the log is currently at false, and after calling acquire, the log is true. And after calling release, the log should be false again, and it will be deleted. Yeah, basically this is the behavior I am expecting. Now we're gonna try out the try acquire. So we have this try a, let's say pointer log try acquire, and if we now step through this again, we should get first the log to be true. Where is my log? Pointer log. Okay, can like see this here. Now it's true. Then try a should be false because acquire failed. Then we can release, and yeah, we are good again. So now let's move this try acquire above the acquire. There we go. And this should result in that we got a try A of true and the lock is being locked. Yeah, try A is true, the lock is locked, and now we should get an infinity loop where nothing happens because, yeah, we can't acquire. Because the lock is already acquired, and this will take forever. Alright then, how do we now use the template parameter? Let's write our own wait function. So we write our void wait function up here. And actually, let's make this like that. And what our wait function up here does is not just displaying a message beep. I really wanna beep that much. Yeah, maybe let's beep and sleep. So we're gonna do a message beep MB. I don't know if the beeps I can error. I think they are also accepting like these codes, but I'm not quite sure. We're gonna see. And maybe let's wait like a second. And then we would beep again. Now to use this, I should just be able to time and wait here. Too many arguments? What do you have for an issue? Try acquire has not too many. Ah, sorry, of course it has too many, because it needs to go to acquire. I'm stupid. There we go. This should also like just go like that, so we acquire and we have our wait function. Let's see if we're gonna get some message beeping. Yeah, we get a beep. You can hear this. Now we have basically written our own wait function here. This is basically beeping until the lock gets free. Am I maybe able to manually change the lock's value? I'm not quite sure if this is possible. Yeah, the debugger. Let's see. Can I edit value? No, I can't edit the value. I need to go maybe to the raw one. I still can't edit the value. Can I edit this one? Nah. It's a pity. I wanna edit that. Is it maybe somewhere down here? Here's the value. That value, I can edit that value. So let's put this to 0, which should... That should make the lock available. Let's see if I now continue on. Yeah, now we acquired our lock again, and you see that our beeping basically stopped. Now the lock can be released again and deleted. Yeah, so this is basically the standard interface that I'm writing, and what we need to do now is we need to write several more functions around the lock to make this a bit more, yeah, let's say usable, or like, yeah, not usable, but a bit more easy to use and also a bit safer to use. We're gonna start by writing a lock guard, not a Lockhart from Harry Potter, a lock guard. The lock guard is basically an object that acquires a lock in its constructor and releases a lock in the destructor. Lock guard. Basically, the idea of that is that you easily can acquire a lock and release a lock even through your function may abort earlier on because of exceptions or whatever. Basically, that your function basically just creates the lock guard at the beginning of the function or at the beginning of the concurrent block where it accesses the data and needs to lock the data, and basically this is going to be freed automatically. And this is just one step to nice and automatic lock management, but we're going to start with that one. We just need the ILog, and we just write a class, our lock guard. So, guard for locks. Actually, this is like pointless, this comment, but yeah. I like to write pointless comments. So basically what this is gonna have, it's gonna have an ILog pointer, my pointer lock. And this is by default a null pointer. Pointer to manage lock. And we also will be able to have a default constructor. In case somebody may want to default construct this, even though this is a bit pointless. We're not gonna be able to copy, so we're gonna delete this. Actually, I forgot by the SpinLock to delete the sign. There's something you should do here, so we're gonna say operator assign. Yeah, delete. There we go. Same thing will be going for the lock guard, but let me quickly finish this. Pointer lock here. Okay, we're gonna have a destruct, because these two functions make the thing what it is. Maybe we're gonna have a boolean function. Yeah, bool is valid. Const no except, so that we can check if the checks if lock is valid acquired, because if it is valid and you come to the point to calling that function, it is automatically acquired. We're gonna delete assign here as well. So operator or operator equal locguard const locguard lead. So we're gonna start with this function. The functions are actually quite straightforward and easy to implement. So what we're gonna do is I'm gonna say my pointer log is pointer log, and we're gonna say if my pointer log, then we're gonna say my pointer log acquire with no default wait function, or maybe we wanna have a wait function here. I may define something like a default wait function at some point here, but for now I'm just gonna, or I may also alter the default wait function to maybe call back to the operating system by default. And then you can like exchange this if you want. So yeah, the structure also quite straightforward. If we have a log, we're gonna release the log. So just very simple like that. Just call release there and we should be good. Alright, then the isValid function. The isValid function basically just returns pointer log not equal null pointer, and then we should be good with the full functionality of this locguard. Basically the usage of the locguard is also very simple. Instead of doing all that stuff here with the log, we are actually gonna do this a bit different. First of all, not gonna use a pointer now, I'm now just simply creating a SpinLock. Just calling this log here, because the interface is already tested. And then what I can just do, I can include my locguard. And I'm just gonna make this like that, so that you can like see that it gets freed after we are exiting this block. So we're gonna have a locguard janitor, it's often called janitor. Actually, I want to write another constructor here. So an ILog, I don't know, I think this should also work, because I want to be able to pass in a reference to a log. This is a bit more easier. And I have a ref log here, and if we say, actually now because we have a reference means that we don't have a null pointer, we can just simply call acquire like that without doing any additional checkings. So yeah, this would allow us to do this like that. So just create a janitor here, and then we would do some work basically. So int I is equal to 0. Let's put a breakpoint in here, maybe put a breakpoint there, and broker to breakpoint here before we create a janitor. And then you can see that as soon as we hit the first breakpoint, our log is false, so not acquired. Then the janitor comes to place, the log is acquired, and as soon as we leave this block, the log gets freed again, so it's now false, because the janitor automatically cleaned the log up, released it after we have left this block here. And this is basically the idea that is behind all that locking mechanism. So basically this is exactly what I want. Exact behavior, what I want. I mean, we could also like, yeah, maybe we are also writing a log proxy, but I'm gonna maybe set a cut here. Yeah, I may do this in a different video. This video is also long enough. I tend to do too long videos. So if you're interested, then click like, and I'm gonna see if we are doing some more work on that. We maybe write an object guard that automatically guards objects with a specified log, or maybe not with a specified log, but with a specified type of log. So with a specified template arguments. All right then. Thank you for watching. We're gonna see us in the next video. Have a nice day. Don't forget to like and subscribe, especially if you want to see maybe how I write a guarded object. So yeah, thank you for watching. Bye.